Welcome to Learn Commerce PU online classes. Don't forget to like our video and subscribe our YouTube channel for all the updates.
Welcome to our second PU Computer Science online class. In last class, we already studied some important concepts, that is from Boolean algebra, about the Minterm and also the De Morgan's first and the second theorem of De Morgan's, application of the De Morgan's, and also the basic duality of Boolean algebra. Now in today's class we are going to discuss some other important concept about our Minterm and the Maxterm. So the concept is the shorthand Minterm notation, and we know that the symbol using for Minterm, this is the symbol, and such symbol look like our sigma. Clear this point here? Sigma, or just only the sigma short m, short letter m. So this is the symbol of the Minterm. Now the shorthand Minterm notation. So by using some of these steps we are going to solve the shorthand Minterm notation. So the step one is the copy the original terms. Okay, copy the original terms. Step 2, substitute zeros for bad letters, B-A-R-R-A-D, bad letters. The bad letters means, maybe if you are using complement of x is called as the bad letters, complement of x or x bar, or maybe complement of y, y bar is called as the bad letters, B-A-R-R-A-D. And once for non-bad letters, now just if you are using x or y or z without using the complementation is called as the non-bad letter, N-O-N-B-A-R-R-A-D, non-bad letters. And this step 3, express the decimal equivalent of binary word as a subscript of m. Clear this point here? So by using all those steps we are going to solve the shorthand Minterm notation. We know that first of all, copy the original terms, maybe anything or any question, it's there in our question paper. So we are going to take such question. So that is the question is the, or the example we can say as the complement of x and y and z. So this is the question. The question is the complement of x and y and z. And now I am going to take this step 2. And what about this step 2? Substitute zeros for bad letters and ones for non-bad letters here. Maybe complement of x, then sure which number we need to use, the number is the 0 here, and y and z there is no any bad letters here. So just only we are going to use the number as the 1 and 1. That means the complement of x, that is equal to 0. So you have to remember this point, substitute zeros for bad letters. Okay, so the complement of x, what's the number we need to take? The number is the 0, but for y and z no any complement is there. So the number we need to take as the 1 here. So 0, 1, 1 here. Now later next one, step 3, express the decimal equivalent of binary word as a subscript of m. Now I am going to solve this question. So maybe 0, 1, 1, that means the decimal equivalent of binary word. Okay, the decimal equivalent of the binary word as a subscript of m here. So 2 to the power of 0 and 2 to the power of 1, and later next one 2 to the power of 2. So like that we need to use the numbers here. So 2 to the power of 0, 2 to the power of 1 and 2 to the power of 2 here. And later after using some value, binary value for each number, then I am going to use the multiplication, that is 0 into 2 to the power of 2 plus later next one 1 into 2 to the power of 1 and plus 1 into 2 to the power of 0. Clear this point here? So how I completed this line here. So 0 into 2 to the power of 2, 1 into 2 to the power of 1 and 1 into 2 to the power of 0 here. And when you are going to multiply, we know that 0 into 2 to the power of 2, 2 into 2, 2 2s are, that is the 4. Clear this point here. Plus later next one 1 as it is, and when you are going to multiply 2 into 1, 2 1s are, the value is the 2 only, plus later next one 1 into, and always remember it, 2 to the power of 0 that is equal to 1, 8 to the power of 0 that is equal to 1, or maybe 16 to the power of 0 that is equal to 1, 10 to the power of 0, the value is 1 only. So 2 to the power of 0, the value is 1 only. So later next one, after that 0 into 4, when you are going to multiply 0 into 4, always the value is the 0, plus 1 into 2, the value is the 2 here, and plus later next one 1 into 1, the value is the 1. That means we can say when you are going to add the value 0 plus 2 plus 1, the value will get in a 3, that is equal to or 3, or we can say as the M3. Clear this point here. So now how we are thinking, the answer is the, or the result, whatever the result we got it here, it is correct or not here. So you should remember, you can find out whether the result is true or false here just by using the octal table. We know that how many variables are that? Totally there are 3 variables are that. That means complement x, y, z here. So 3 variables are that. 3 variables means sure we need to use the octal table. So first of all we need to use 4 0, and later next one is about over 4 1. Later the second column 2 0 2 1, 2 0 2 1 here, and the third column 0 1 0 1 0 1 0 1. Clear this point here. Now we know that 0, and this is the 1, this is the 2, and this is the 3 and 4 and 5 6, and later next one the value is the 7. Now m of 3, the m of 3 is the, that is the 0 1 1. Clear this point here. The m of 3, the value is the 0 1 1. So now what's the result? The result is the 3. Clear this point. The result after that we will get the result as the 3 here. So we can say that this is our correct answer. Clear this point here. So like that we can find out whether the result is correct or not here. So this is by using all those steps, the shorthand Minterm notation. Now let's, like that only we are going to solve one more problem. The problem is the A complement of B, complement of B, C and complement of D. So the question is the A complement of B, C complement of D here. We know that. So that means that this is the copy the original terms, and second one, substitute zeros for bad letters. So 1, A value is the 1, complement B value is the 0, C value is also a 1, but complement D value is the 0. So like that we can take the first step. Clear this point here. So copy the original terms here, and later substitute zeros for bad and letters, and the ones for non-bad letters we already completed, and later next one express the decimal equivalent of a binary word as a subscript of m here. So that means we know that here. So 2 to the power of 0 and 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. So clear this point here. So like that we need to use the value, the binary, the decimal equivalent binary word as a subscript of m. Okay. So first of all I am going to start the value, that is from our right side. 2 to the power of 0, 2 to the power of 1, 2 to the power of 2 and 2 to the power of 3. Now just only the multiplication, 1 into 2 to the power of 3 into plus 2, 0 into 2 to the power of 2 plus 1 into 2 to the power of 1 and 0 into 2 to the power of 0. So clear this point here. How I completed, just only I make the simplification, that is the 1 into 2 to the power of 3 plus 0 into 2 to the power of 2 plus 1 into 2 to the power of 1 plus 0 into 2 to the power of 0, and later next one we know that 1 into, that means 3 times we need to make the calculation, 2 into into 2 into 2. 2 2s are 4, 4 2s are 8 here. So like that, clear this point here. How I got the value 8. So 3 times we need to make the calculation. 2 into 2 into 2. 2 2s are 4, 4 2s are 8 plus 0 into, we know that 2 times 2 into 2. So 2 2s are, the value is the 4 plus 1 into 2 to the power of 1. 2 1s are 2 plus, and we know that always 2 to the power of 0, the value is equal to 1 only. Clear this point here. The value is equal to 1. Later 1 into 8, the value is 8 plus 0 into 4. Always when you are going to multiply any value with the 0, always the result is the 0 only, plus 1 into 2, the value is the 2 here, and later next one is about our 0 into 1, the value is the 0 only. So when you are adding the value 8 plus 0 plus 2 plus 0, the value is the 10. Clear this point here. So the value is the 10, that is equal to small letter M10. Clear this point, the small letter M10. And how we are going to find out the result is correct or not here? We know that depend on the variable. So in our first example, what I said, there are just only 3 variables are there, that is complement x, y, z, 3 variables. So we need to use the table like our octal table. But when the variable going to increase, that is equal to the 4 variables. So a, b, c, d, or maybe the x, y, z, w, maybe the 4 variables, any name of the variables are there, maybe that is equal to the 4 variables. That means sure we need to use the hexadecimal table. Clear this point here, hexadecimal table. So totally in first column we need to use 8 rows, 8 0, 8 1, okay. In second column 4 0, 4 1, 4 0, 4 1. In third column 2 0, 2 1, 2 0, 2 1. And in our fourth column 0 1, 0 1. So like that, when you are going to use the value 10, when you are going to write the value 10 of the hexadecimal number, will get the values, the value that is equal to 1010. So clear this point here. So like that we can find out whether our result is correct or not here. So clear this point. So this is about our some shorthand Minterm. So again, first of all, the first step is the copy the original terms here. Second one, substitute zeros for bad letters and ones for non-bad letters here. And third step is the express the decimal equivalent of the binary word as a subscript of the M. Clear this point here. Express the decimal equivalent of binary word as a subscript of M, that is equal to M10. And our first example, the result is the 3, and we know that how we are going to find out whether the result is true or false here. And in case of the next example, that is the ABCD, the result is also equal to 10 here. That is going to write by using M10. Clear this point. So the Minterm is considered as the small letter M here. So that is equal to M10, or just only the result is the 10 here. And after completing the shorthand Minterm notation, now the next thing is the Maxterms. We know the meaning of the Minterm, correct? Now what do you mean by a Minterm? Minterm is a product of all the literals with or without the bar within the logic system. Clear this point here. The Minterm is a product of all the literals with or without the bar within the logic system. And so this is the example of the Minterm, x and y and z. Clear this point, x and y and z. Now after completing Minterm, after knowing what's the meaning of the Minterm or the definition of the Minterm by using the example, now our next thing is about the Maxterms. And in our Maxterm, the symbol going to use pi, capital letter M, or simply we can say as the capital M, okay. The symbol of the Maxterm. Now we are in the concept of Maxterm, and the symbol specially for Maxterm going to use as the pi, capital M, or just only the capital M. So this is about the symbol. Now the Maxterm. So Maxterm is a sum of all the literals. The spelling of sum I used here, the sum SUM. Clear this point? SUM. So Maxterm is a sum of all the literals with or without the bar within the logic system. So one example I want to write as the x plus y plus z. Clear this point here? For Minterm, how I completed x and y and z. So this is the example for Minterm. Now the next example, how I completed the example for the Maxterm, x plus y plus z. So this is the example for the Maxterm. The Maxterm means the Maxterm is the sum of all the literals. Literals means here which consist of a single variable or its complement is called as the literals. Okay. So the is the sum of all the literals with or without the bar within the logic system. So this is the definition of the Maxterm. Now let's what about the or what's the meaning or the example how we are going to take the value for 0 and also the value for the 1. So if the value of the variable is 1, then its complement is added. Clear this point here? For Minterm, if the value of the variable is 0, for variable with value 0 we are going to use the complement. But what about in case of the Maxterm? If a value of the variable is 1, then its complement is added, otherwise the variable is added as it is. Clear this point here? So for x as it is I am going to take, okay, why? Because x value is equal to 0, but where I am going to use the complement when the value of variable is equal to 1, okay. So complement of y plus complement of z. So this is the example for the Minterm, or we can say that x is equal to 0, y is equal to 1, z is equal to 1, then Maxterm will be x plus complement of y plus complement of z. Or maybe the second example, maybe our x value is equal to 1 and later y value is equal to 0. How we are going to write the Maxterm? That means if the value of the variable is 1, then complement is added. That means sure we need to use the complement of x, but no any complement for the y, because the y value is equal to 0. So no any complementation, but we need to take the complementation to the variable z, okay, the complement of z here, the complement of z. So the Maxterm will be complement x plus y plus complement of the z here. So depend on the value 0 or 1, we are going to change the complementation or without complementation. So this is the meaning of the Maxterm. So clear the meaning of the Maxterm. Again I am going to tell why, because it's very important concept. The Maxterm, the pi capital M, or just simply this symbol going to use for Maxterm, that is equal to the capital M, okay. And Maxterm is a sum, SUM, sum of all the literals with or without the bar within the logic system. And how we are going to take the complementation to any variable. If the value of the variable is 1, then complement is going to add, otherwise the variable going to take as it is. So clear this point here? So this is the meaning and the example or the symbol going to use in our Maxterm. Now the Minterm, maybe one example, maybe if any doubt or anything after Minterm, it will be going to clear for Minterm as well as the Maxterm. We know the example now, just only we completed one example with the meaning and definition of the Maxterm and also with the symbol. Now Minterm, I want to complete one example for the Minterm. So Minterm, x is equal to 0, y is equal to 1, z is equal to 1. So how we are going to use x and y and z, correct? No, x and y and z, but where you are going to use the complementation for variable with value 0, then take its complement, that is in our Minterm. So like that we are going to take complement x and y and z. So this is the answer of the Minterm. Clear this point here? So this is the answer of the Minterm. Now later next one I am going to complete Maxterm as well as the Minterm here. Now first of all I am going to complete for the Maxterm. So how I am using x plus y plus w. Clear this point here? but where we need to take the complementation to the variable in Maxterm when if the value of the variable is 1. So complement, and later next one complement. So this is the answer of the Maxterm. So the complement x plus y plus z plus complement of w. Clear this point here? Now later next one Minterm. The Minterm is the x and y and z and w. So x and y and z and w, but x value is equal to 1. Whether we are using the complementation? No. So in our Minterm, that means for variable with value 0, then take its complementation. So complement y and complement z. Clear this point? So this is the answer of the Minterm, x and complement of y and complement z and w. So clear this point here? So this is some information about our Minterm as well as the Maxterm. After completing the Maxterm example and also the definition, now let's next thing about shorthand Maxterm notation. The concept is the shorthand Maxterm notation. In our shorthand Maxterm notation, the same steps we are going to use. These steps is the copy the original terms and also substitute, but in our Maxterm, our 1 for bad letters and zeros for non-bad letters here, and later next one express the decimal equivalent of binary word as a subscript of capital M. So we know that in our Maxterm, the symbol going to use, that is pi, capital M, or just only capital M with a capital M with a subscript. Okay, and in this example, the Maxterm, the value is the 1001. The value is the 1001, whose, or we can say that all are the input combinations. So the value 1001, the result should get it as the 9. Clear this point? The 1001, the result is the 9. So we know that how we are going to find out the value, whether the result is true or false here. It depends on the variables. The variables is equal to 4. The variable names are x, y, z, w. So that is equal to 4 variables are there here. So maybe if 4 variables are there, then sure we are going to use the hexadecimal table, and hexadecimal table, that is equal to 0 to 15, that is equal to 16. So 8081 and 4041, 4041, 2021, 2021 in third column, in last column 010101. So like that we are going to complete till the end of the 15 value. Now let's whether the value will the result will get as the 9 or not here. We know that, but because this step 1 copy the original terms, that is the 1001 depend on the variable. So 1001, 1001, and we know that substitute in our Maxterm 1 for bad letters and zeros for non-bad letters. And zeros for non-bad letters here. So complement of x plus y plus z plus complement of the w. Now I am going to find out by using the step 3. 1001 and 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. So 1 into 2 to the power of 3 plus 0 into 2 to the power of 2 plus 0 into 2 to the power of 1 and 1 into 2 to the power of 0. So in this line I completed just by using the values and by providing the binary equivalent, decimal equivalent value to each variable, to each values. 1 into 2 to the power of 3 plus 0 into 2 to the power of 2 plus 0 into 2 to the power of 1 plus 1 into 2 to the power of 0, and 1 into 3 times we need to make the multiplication. 2 into 2 into 2, the value is equal to 8 plus 0 into 2 times 2 into 2, the value is the 4, and 0 into 1 time 2 ones are 2 plus 1 into 2 to the power of 0. We know that always the value that is equal to 1 only. 2 to the power of 0, the value is equal to 1 only. Now 1 into 8, 8 plus 0 into 4, the value is the 0, plus 0 into 2, the value is the 0 here, and later next one is about 1. We can say that plus 1 into 1, the value is the 1 only. When you are going to add 8 plus 0 plus 1, the value is equal to capital 9. Clear this one, capital M9, or just only we can say as the value is equal to 9 here. And when you are going to find out by using the hexadecimal table, that means the 8081 in first column, 4041 in second column, 2021 in third column, and in last column 010101. When you are going to reach to the value 9 here, will get the value as the 1001 here. So we can say that our result is correct. Clear this point here. So this is about our shorthand Maxterm notation. So completing the shorthand Maxterm notation, now let's about our canonical expression. Now, what do you mean by a canonical expression? So we can say the Boolean expression. We know the example for the Boolean expression: x plus y plus z, x plus yz, x plus complement yz. All are the example for the Boolean expression. Okay. So a Boolean expression composed entirely either of Minterm, only for the Minterm, or composed entirely only for the Maxterm, is referred to as canonical expression. Maybe little bit doubt, why? Because after completing all those problems, it will be clear to everyone what I am going to tell in definition, or what's the definition of the canonical expression. So now just the definition I want to tell in this concept. The canonical expression is the composed, that means the Boolean expression. We know the example for the Boolean expression. The Boolean expression that is going to composed entirely, maybe for the Minterms or maybe for just for the Maxterm, is referred to as the canonical expressions. And such canonical expression can be represented in two forms. There are two types are there, two methods are there in our canonical expression. The forms, methods or types are: first one is the sum of the product, SUM, sum of the products, that is equal to the short form SOP, that is equal to the Minterm. Clear this point here. The first thing is the SUM, sum of the products, short form SOP, that is equal to the Minterm. And later next one is the product of the sums. Okay, the product of the sum, that is equal to short form is the POS, that is equal to the Maxterm. So clear this point here. So we can say that in our canonical expression, maybe you are going to represent only for our Minterm, that is called as the SOP, only for the Maxterm, that is called as the POS here, that is called as the POS here. So this is about some in explanation about our canonical expression. Thank you.
Don't forget to like our video and subscribe our YouTube channel for all the updates.